And until I fix the distribution, we'll just go ahead and move on to some additional topics. And the topic that we're going to move on to is going to be sensors. What I'll do is I'm just going to use the Android documentation for that purpose. And then we'll run some sample programs, or at least write some sample programs that you can try out on your own mobile device. And this is the link that we are using in order to kind of learn how to deal with multiple sensors on your devices. Okay, so for the most part, I'm going to read some of this stuff here and then go through some of the explanation. And then we can also write the app on the side, so that way we can kind of see how to write an application that makes use of sensors. The nice thing about this is Android, the framework, is including a class to deal with all the different types of sensors using a single, a few classes. And what I'll do is I'm going to move, skip this part. I mean, this part is really something that we know already, like the different types of motion sensors, environmental sensors, position sensors, and stuff like that. So I'm going to skip all that stuff and get to the sensor framework itself, and get to some of the coding part, like right here. Okay, there we go. So we have, here the sensor framework in Android, and what you need to do, with using sensors is first you need to get a sensor manager. Okay, so what a sensor manager is really just a class that represents a connection to the surface of the Android framework, the Android operating system, and that's what the manager is. It's really just a class, or representing a surface to the Android operating system. And through this object, you can request and say, okay, I need access to a particular type of sensor. The second one is sensor itself, which is very important because this one encapsulates everything that is related to a particular sensor. It's not a sensor manager, it is a particular sensor. So if you find a particular sensor, let's say a quote-unquote compass, which is actually called a magneto device on the Android, in the Android framework, then it can be represented by a sensor object, and then from here on, it will be handled through this object. Sensor event is an object that is sent back to you whenever there's an event related to the sensor that you want to have feedback, like, okay, the orientation just changed, okay, do something about it. And sensor event listener is something that you have to implement in order to say, okay, if something happens to this sensor, I want this to be the object to handle that particular event. In other words, sensor event listener is really about the same as an on-click listener, okay, except it's not responding to someone touching something on the screen or clicking something on the screen. Instead, it is reacting to a sensor, getting something changed. The value can be changing, the accuracy can be changing, but it will be going through this object to respond to it. The first thing you need to do if you want to use a particular sensor is to find out what sensor it is, and also find out whether that sensor is supported by a particular version of Android. So this gives you a pretty easy to read table as far as if you want to use, let's say you want to use a gyroscope. Okay, the gyroscope sensor cannot be used with Android 2.2 or before. I mean, if you just look up this table, the fourth row is gyroscope, and you just can't use it. So this table gives you a pretty good idea of version 2.3 is kind of like a important part, because you can see that a lot of sensors that were not supported before 2.3 are now supported after 2.3. And then 4.0 added some additional support for ambient temperature and also for relative humidity. But those are device specific or mobile device specific, which means just because the operating system supports that type of sensor doesn't mean that you have that type of sensor on your actual device. Okay. All right. So once you know what type of sensor you may be supported, depending on the operating system that you're dealing with, then you can try to identify and say, okay, I want to know whether this sensor is actually available or not. And this is the code to get the sensor manager instantiated. So in this case, you can see that the sensor manager is not instantiated by a new operator. it is actually done by getSystemSurface. Now, getSystemSurface is a kind of more or less generic call. It is really used to get any type of system surface. But in this particular case, we're getting a very specific system surface, which is to give me a sensor manager, and that's why you have to cast it, or cast whatever is returned by getSystemSurface into sensor manager. If I right-click on this link here, I can actually see the method itself. It is a method defined inside the context class, and inside the context class, you can see that it just returns a single object. And that object is really the superclass of everything. Okay, the Java class object is the superclass of every other classes. So that's why you can cast it to just about anything. The string, on the other hand, is basically telling the operating system what kind of surface are you requesting. In this case, we're requesting a surface on sensor. So if you look up sensor surface. It is a particular string. It is predefined to just sensor, SENSOR, and that's being passed to that particular method. And the context and activity is a subclass of a context. So that's basically, that means when you want to place this call to get system surface, you have to do it inside the activity, or otherwise you have to specify which activity is going to use this particular method. That's because an activity is a subclass of context, and this method is defined inside the context class. Are we doing okay so far with this part here? So instead of just talking about this, which you can also do on your own, what I'll do is I'm going to start up Eclipse, and we'll be just doing some programming along the side. I can't really show you the screen of my mobile device, but at least we can actually get the program written at the same time, and this way you can also see how all the pieces are supposed to connect and become a single application. So I'm just going to run Eclipse here, and we do have a micro USB cable, so I can hook it up and use my actual phone as a programming device. The only reason why I want to do that is because the emulator does not have emulated devices. So there's no way to actually run this code and say, oh, okay, here's the position sensor. All right. So I'm putting the Bluetooth code on hold for the time being, and we'll go ahead and start a new Java application project on sensors. So we'll just call this test sensors, and I'll just go use the typical package name by using the school address here and my own name. And this time I want to double check and make sure my minimum required SDK is not API 8. I want it to be at least gingerbread, or more ideally speaking, maybe ice cream sandwich, because it supports all of the sensor types. Right, so let's move forward, forward. So I'm just taking the default for everything for the time being, and then we'll just we'll go ahead and modify this stuff and actually get it to work with the sensors. There we go. All right. So inside activity main, which is an activity subclass. That's the layout. I need to look at the source code. In onCreate, I'm going to create, well, first of all, main activity as a subclass of activity. I need to internally keep track of the sensor manager. So I need to define my own private member that is of the type sensor manager, because I need to refer to it from time to time. So I have a private member here. It is of the type or the class sensor manager, and I'll just call that sensor manager as the name of that particular member, and it just takes an import here. Okay, there we go. All right. So the first thing we need to do is to instantiate or have this reference to actually refer to an object that represents a sensor manager from the operating system's perspective. And we can do it in here, okay, inside the onCreate. We can just say, sensor manager is get. Now, if you want to know, what type of parameter is, okay, I have a typo here. Sensor manager, okay, gets, sensor manager, okay, that's good, okay. So if you want to get, if you cannot remember the name of the subroutine call, if you just type, get, sensor manager, it's not going to give you any prompts. But you can always do it this way because this is representing the object that is, actually doing the call. So this time, I can, use get sensor, get system service. Excuse me, I got it here. Okay. Get system service. There we go. And the name that we want is basically just sensor. If you want to, you can use double quote, sensor and double quote. That will work too. But if you refer to the document basically wants to use context dot sensor surface because it is a predefined string inside the context class as a static definition. So we'll go ahead and just use that, which is context dot, and of course my memory is sensor surface. There we go. And it's highlighting it because it cannot convert from object to sensor manager because it is just returning a generic object. So this means we can now do a downcast from here and cast it back into a sensor manager object. Okay. So here's my blue. Yep, go ahead.
Oh, sorry, but Monday's videos were not uploaded.
It's not uploaded. Oh, okay. Monday is
28th.
The 28th. Okay. Let me see if I. The 28th. I just uploaded it in my office, so it should be there already. 29th, 28th, they're uploaded, but they're rejected because they're duplicate. Oh, okay, because I forgot to publish.
Okay.
Yeah, there we go.
I just want to make note of this before they're deleted on your side.
Good idea. All right, so now we have a sensor manager instantiated, but once you have sensor manager, we can do other things.
I'm not sure if I understand why you have to put this in front of the get system service.
You mean the casting?
No, not the casting part, but specifying.
Oh, the this?
Yeah.
You don't have to because if you cannot remember the name of the method and you want the system or if you want Eclipse to automatically prompt you, there's no way to make it automatically prompt you if you don't specify the type first.
Okay.
So this is my trick to trick the system to give me some help as far as spelling the method is concerned.
So what would you put there if you were to remove this?
To remove?
Yeah, what would you put there if you were to remove this?
Well, you can just remove this. Once you know this is the right name, this is useless, because it's automatically assumed that this is a method of this object, so it's not really required. That particular this followed by a period is not required because everything is implied to be a method of the class that we are defining or a superclass thereof. It's just that I put this here, so that it prompts me for the name, so I can spell a part of it.
To help you out.
Yeah. Yep. Exactly.
Okay.
Yep. It's just me being lazy and not having to remember.
I
the
thought it was
exact name.
referring to main activity without any specification of what you're
Without
referring
any-
to.
Sorry.
I thought it was referring to main activity if you don't have anything there to specify.
Oh, okay. No, it's just me trying to get Eclipse to help me spell out the name of the methods.
Tricking the IDE. Tricking the IDE.
Yes. Yeah, the IDE helps, really helps, because otherwise I would have a browser open up like 20, 30 tabs, just to find the names and get to the right points. Okay, now the sensor manager doesn't do a single thing, even though it is now instantiated and I have a reference to it. It doesn't do a single thing that is useful until you ask it to do something. So if we refer back to the documentation here, on using the Android documentation, so the next thing you want to do is to basically use either get sensor list or get default sensor to find out what sensor is available for a particular type. Now this call here, okay, if you just focus on this call here, this one will give you all of the sensors on this particular mobile device. Okay, not just one, but all the sensors that are available on this particular device. And the return type is also kind of interesting because it is what we call a template class in C++ or a generic class in Java. In other words, it is a list of certain types. Okay, each item in the list is of the type sensor. So this gives you an idea of, once you get this particular data structure or once you get a reference to device sensors, then you can go through that list and actually enumerate through it and print it out. Okay, this is the first device, this is the second device, and so on. So you can actually make a list of all the devices available in your system using this particular call or using this particular method. So let's go ahead and do this part here. Okay, and we'll kind of deviate from the example in the documentation. So instead of just going through this and say, okay, this is what we can do, instead of doing that, what we'll do is inside our fragment, what we'll do is we'll basically create a user interface that will list everything like this, and then we'll just keep an eye on, okay, what is available on this particular device. So the first thing we need to do is to change the user interface. Go to Fragment main, and we'll just drag a button to trigger the operation. So we'll go to button, we'll take a small button here, and then we will program the button to go through that list. Now once we have this type of thing, there are two ways to do it. If you don't want to go through the trouble to create a new class so that you can encapsulate everything into a new class, you can still have everything contained mostly within main activity, because the fragment knows where to find its own activity, the activity that is containing it. So we can actually do it that way too. So that means in here or inside the actual code, main activity. So what we can do here is we'll go ahead and specify what that button is supposed to do. So inside onCreateView, after root view itself is created, what we'll do is we'll specify the Onclicklistener to that particular button. This we have done quite a few times already. So we can start with a typecast into main activity and get activity here. The cast is not really needed because all we want to do is to specify the Onclicklistener. And then here we can say find view by ID. And r.id. This one is the button. It doesn't show because I haven't saved all the files yet. So we'll ask it again. And this time button 1 shows up. And once we find the view, we can now specify the Onclicklistener. So we can now say set Onclicklistener and put a semicolon at the end. And then inside here we can use a anonymous class. So that means we have to say new Onclicklistener parentheses, and then we can specify the class over here. It's complaining that import it first. and then we want to add in unimplemented methods. So that's it. So inside this onClick here, we want to ask the operating system, or to be more specific, we want to trigger the logic to get all the possible devices, and then we want to populate all the different sensors, and then we want to populate something in the fragment so that we can say, okay, we have all of these things available. Okay. So if we go back to the fragment, which is the design of the fragment, now we have to think about, okay, where do we want to put all of that, the devices? We can just go ahead and use a list view like last time. I think that would be, one way to do it. The other way to do it is just use a text box, multi-line text box, and then we can just populate those lines to include, to list all the possible sensors, all the sensors on this particular device. Which way do you guys want to do it? Do you want to kind of reuse the list view so that we have a second review of how to use list view? Okay. So list view is under composite. So we will drag a list view into here. And the list view, is kind of big. By its nature, by default, it would take up the rest of the space on a particular screen. So that's why it is now taking up pretty much the rest of the screen here. So with that already done, we can go back to our Android code in main activity. So instead of specifying the entire logic here, I'm going to send it to a particular method inside main activity to do the rest. Okay. So to do that, I'm going to trigger an operation of the main activity. So inside here, I can use a get activity, but I have to cast it into main activity because otherwise it will just give me it will give me an activity object, but not of the subclass main activity. So I have to cast it to main activity first, and then once I have that, I can now specify a particular method of main activity. So in this case, I can just give that particular method a name. Let's say populate sensor list. Okay. Now, when I populate sensor list, I also need to give it the list view, which means I need to find the list view, create an object out of it, and then pass it as a parameter. So to do that, I'm just thinking which way is more clear, because I can do it the not so clear way. The not so clear way is just to go through all of the method calls that I need in order to get it right at this point. So I can just do it at this point. Okay, we can use get activity first to get back to the activity. Once we have the activity, we can then use, take it back. Find view by ID is a method of the fragment already, so I think that will work. Okay, it is a method of get activity. So here we have to do the same thing here. So get activity dot find view by ID, and I forgot to save all the files first. So now we have all the files saved. And then inside find view by ID, we'll go ahead and find r.id.listview, listview1, and then we have to cast it to a list view because otherwise it just returns a generic view. We want to make sure that it is a list view because that's what the other method is going to expect. And make sure that we have the parentheses specified here.
not encapsulating get activity.
Hmm? We're not.
Your
Well,
parentheses.
The parentheses.
No, do another parenthesis in front of Listview.
It's the one on the 76.
Okay, let me import it first so we get rid of that particular warning. Okay, so this is casting this part.
Okay.
That close paren is going to close this parenthesis. So we are just missing the method here because I have not defined that particular method. Okay, so this is okay. You know, we're actually okay at this point because I need to implement that particular method now. So let's see if we can automatically do it. Yep. Create method populate Listview in main activity. Nice. All right, so now we are back to main activity, and where's my method? It's probably below. Yep, there we go. Okay, so this is automatically generated by when I clicked on Eclipse, and it said, I'm referring to a method that is not implemented yet. So it gave me the stub, and I need to populate the stub now. Okay, so inside the stub, the first thing I need to do is to have a list of sensors, and then basically use this call to get back a list of all the different sensors. That's the first thing I need to do. So we'll go ahead. In this case, it's okay to just copy and paste because it's really that's the code that I need to use. It's having a problem because I did not use this particular name. I used just lowercase s for sensor. The class sensor is not imported yet, so we'll go ahead and import that. And then the class list is also not imported yet, so we'll go ahead and import that also. So that clears away all the errors for this particular line. And now we can do something about that list. So when we want to do something about the list, unfortunately it's not like last time when we are doing something about a set. A set has a kind of built-in feature in Java to go through all the items within a set. But when we're talking about list, it doesn't have the same feature. So what we'll have to do in this case is to use a counter to actually get through the multiple items inside the list. This Java code actually has it shows you how to do this. There is later on there's a loop here. It shows you how to go through a list. So you have to use a particular integer to control which element inside the list we are accessing. And then you can use the size of a list in order to tell you, okay, when do I stop? That's basically the length of the list in terms of number of items. And then using a for loop, a regular for loop, you have to use I++ as a post operation to increment the counter to move on to the next group. So we'll use basically the same construct here to go through that list, except in this case, I'm not limiting myself only to one particular type of sensor. I'm looking at all the possible sensors on my mobile device. So in this case, we have a for loop, int I equals 0. I'm creating the integer at the same time when I'm initializing it. And as long as I is less than device sensors dot length size, we want to perform one iteration, and then after each iteration, I want to increment the counter I.
That's pre-increment.
Well, that's fine. You can use pre-increment or post-increment because the incrementing is not used inside of any context to make use of its value. So in a context that is not making use of its value, depending on the compiler, pre-increment is usually quote-unquote faster because it doesn't have to keep track of the old value of the counter and then you present it to no one, basically, in this case, because no one cares about the actual value of the expression. All we want to do is to just add one to I. So you can use pre-increment or post-increment here. It doesn't really matter. And then the other thing we want to do is to either populate an array, or we can use an array adapter like last time, to so that later on we can use that array adapter and link it with the list view that we have already. It's already passed here. Okay. So several ways to do this. We'll do it the same way as last time. So the first thing we need to do is to have an array adapter. I think it's OR. It's an adapter of strings. So this is basically an array of strings, pretty much. So and we'll use an E. There we go. So we can just import that and create this object here. So we'll say this is my array adapter, and we have to create the array adapter. So we'll create array adapter string. Displays constructs. Of course, I cannot remember how we did it last time, so that's why we have the other program still here. We can just go back and refer to that code. Inside main activity. Right here, found it.
Okay.
So we initialize it by calling array adapter string, and then we have to present the activity itself, layout, android.r.layout simple list item underscore 1. So we'll do exactly the same thing here. In fact, I'm just gonna do a copy and paste. Of this guy anymore, and the only thing that we have to change is main activity, because we're already in main activity, so this means this will be fine, okay, because we're already, this is a method of main activity already, so this is okay. Okay. Now inside the loop here, for each device that I find, I want to add a few entries, or I want to add an entry to the array adapter. So inside here we say array adapter dot, we just need to add a string in this case, so we'll go ahead and just add a string. So inside here the string will refer to the device itself, so we say device sensors dot get, and get allows you to specify which location. In other words, it's kind of like the indexing operator, the square brackets, except it applies to a list in this case instead of a regular array, and I is my counter here. So once I have the get method, the return value of a get method is basically in this case a device, a sensor object. So now I can basically specify, okay, what type of sensor, what is the name of the sensor? I can get the name, I can get the vendor, or I can convert the sensor itself to string, which is a basic description of what it is. Yep.
Is it a zero-based array?
Yes, it is.
Don't you need to do a -1 right there?
Do a -1?
Yeah. Because you come in.
I start with a 0.
Yeah. But then you're comparing against I. Oh no, wait, yeah, okay.
Yep. It's going to be okay. So
Doesn't
we'll
take
go
much.
ahead and just specify toString. Basically it is a string that describes the that particular device, and we'll find out exactly. Okay, it says right here, returns a string containing a concise human readable description of this object, and the object that we're dealing with here is a sensor. So we'll just go ahead and see how well this works. We also have to associate the array adapter to the list view. So now we have to say Listview dot I think it's set adapter. Let me go back to the other one just to double check, make sure. Yep, Listview and set adapter, exactly. Okay, so that's what we need to do. So we have here set adapter, and then we specify array adapter. I think that's all we need to do to populate the list view. And just double check. I think there was one more thing that I had to do. Okay, LV set adapter is what we need to specify. And that's it. That's all we have to do. All right. So this code should be done already. And we just need to check for other types of errors, and then I'll run it. No errors here. There we go. It's all clear. And I'm gonna run the screenshot tool. I found a tool that allows me to do a screenshot. It's really slow, but at least it will give you an idea of what is happening on the screen. So we'll go ahead and do it that way.
It's like 1 frame every 3 seconds.
Yeah, something like that. But at least it works okay, for the purpose that for whatever we're doing here. So we'll go to the downloads folder, and it's called Drive as Screen. And the way to run it is just to run java-jar, and then the file name of the jar file. And this is this is how it looks. This is what it looks like. And it's going to ask for permission to the screen. I have to click yes, allow it first. And I have to control the zoom because otherwise it takes up way too much space on the screen. So we'll go to the zoom, default zoom, and we'll make it, let's try 20-something% and see if it works better. Because right now it's really huge. This is actually what is being displayed on my screen, on the Android side. Okay, so it's still kind of big. Let's go to 25%. And while it is doing this, we'll go ahead and run the program. So here we'll go ahead and run the program on my actual device. What is Eclipse doing? It's launched, but it has a problem. It closed prematurely. All right, that's fine. So what do you do when your program doesn't work like this? It just kind of crashed out. What would you do?
Give up.
Hmm?
Oh, I said give up.
Just give up and ask tech. My program is not working. What am I going to do with it?
First, make
Yep.
sure you have a target set.
A target set.
Yeah, Android device, virtual machine. Right now, I'm just thinking it doesn't find anything, just crashed it in response.
No, it found it. It's just, it's.
Did your phone install the app install on your phone?
Yeah.
It did?
Yeah, it just crashed.
Oh.
It just crashed out of it. So it is probably a null pointer somewhere, and the way to detect, where it is having problem with is to run the debugger. I mean, that really is the first thing you do, is to run the debugger. So instead of running it, without a debugger, run it with a debugger. So this way, if it does crash out, it will stop, where the problem is. Okay, so this is the statement where the problem is, and it's not even within my subroutine. So it is inside activity thread.
In debug, you can see the stack.
We can actually, I think we can go to window and go into the debug perspective. Yep. So there we go. And this is the stack. This is how we got to this point. And if you backtrack, we'll be able to find out, how we got here in the first place. Why not? Okay, so we are getting here inside the looper.
I think it's string.
Yeah, but I can't track back to my own code. There's nothing here that is corresponding to my own code. Okay, if that is happening, the other way to debug this type of program is to take out stuff, step by step. Okay, so if I go back to my own program, which is not really long at this point, so you have to ask, okay, what can possibly cause this to happen? Can it be this call here? Okay, so basically we are just ruling out things, one by one. Can it be this particular method that's causing problem? Cannot be. How does this method get called? How do we trigger the execution in here? I have to click something, right? Okay. I haven't even seen the screen yet. Okay, so I have not gotten to the point where I can click something. So it cannot be this call. I don't have to suspect anything in here. So whatever is causing this problem, it has to be this call here, because this is pretty much the only thing that I'm adding. Can be this one. It can also be sensor manager getting instantiated. Yep.
I think it's find view by ID, maybe throwing another null.
Yep. Returning a null. Yep. That is entirely possible.
And you just move the V over.
Something.
Drag the V over in front of L and create.
But I just did something.
Yeah, when you're moving mouse, you accidentally drag the V, the letter V over.
I see. There we go. All right. So it can. It's probably this find view by ID, not finding. Oh, you know what? I know exactly why. Because I'm using the activity, and the activity doesn't have that particular item. It is the root view that has this item. Or I can basically say get view, because get view is also a method of a fragment, so that will fix the problem. Okay, keep forgetting that part. So let's go ahead and save. Should I just run it without debugger, or should I run it with debugger? Are we feeling brave, or?
That button should just be called "Are you feeling lucky?"
Are you feeling lucky? Oh, guess not. Okay, but not this time. I'll just kind of go through the message and find out why it's complaining. Okay, so let's see. So what we need to do is to find out where in my code it is causing a problem. We're inside Fragment Manager. It is a null pointer exception. Inside onCreateView on line 73. So that's basically what we need to look at. It's line 73, which is this one, returning a null pointer. So with a null pointer, we cannot do a set Onclicklistener. Okay. So let's see. Do this. Save. so this time it is running. I'm going to display the screen. I don't think it's going to show a whole lot because I have no idea. Oh, there we go. We can drag it.
I think the window's just oversized.
Yeah, super
Shrink it.
oversized. And if I click this, current scale is 75%, and we can. Nope, doesn't want to change it. It's set to.
Looks like it's just scaling the window itself, not the content.
Yep.
And actually getting bigger.
The other thing is to see if I can click here. Nope, it doesn't do anything. So I have to actually, it's just a viewer of what is on my screen. There we go. So I'm going to click the button, and it did populate a whole bunch of stuff. Okay, so let's see if we can. Okay, if it doesn't work in one direction, we'll try the other direction. Right?
Just make it bigger and bigger, make it smaller.
Yep. It's just flipping it. I think that's just rotation. Yep. Current scale, take a screenshot, continuously record. Okay. And show all device properties. Well, this is enough. I just have to show you a few of these items. So let's go ahead and take one screenshot, save it, and then we can just look at the screenshot there. Takes a screenshot and save it to a file. Okay. It's not saving it.
It may be saving it to where it's being run from.
If that screenshot is not working, I have other screenshot tools. How about this? I just need to take a screenshot of a few items. And we'll save this one. Temp folder is fine. I don't need to look at it later. So we'll go to File Manager. Folder. Here's my screenshot. There we go. All right. So I just took a little screenshot. My screen is timing out again. So this is basically what each item looks like. The first item is the sensor name is MPU 6515 accelerometer, and then it gives me the information about the vendor. So in this case, the vendor is InvenSense, version 1, type 1. Maximum range is 39.226593, and that is in a particular unit. Okay, I believe this is in meters per second squared. Resolution is 5.95 blah 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 to the power times 10 to the power of -4. Power is 0.45. The power is actually reflecting how much power is consumed by the sensor. Okay. And I would imagine the unit here is probably in milliwatts. I cannot imagine it's taking 0.45 watts. I mean, that's just way too much. My battery will be dead in no time if that's consuming 0.45 watts. So I think this is actually in 0.45 milliwatt. You can look up the documentation and find out exactly what these units are really talking about. Minimum delay is 5,000. That's 5,000 microseconds. Okay. So that means every 5 milliseconds I can get an update of the value of this particular sensor. The second one is a magnetometer, and the vendor is AKM, version is 1, type 2, and that is in what is the unit of a magnetic flux. We have an engine here. It starts with the uppercase T. That's the Tesla. I think that's. Okay, the documentation talks about the unit, but it doesn't really talk about what. Maybe not this one. Somewhere it talks about the units. So each type of sensor gives you the information, and the information. Okay, let me just kind of go back to my screenshot. So the unit is actually in a sense that makes sense, but you can also see that I have 2 entries for the magnetometer. This is the first one, and this is the second one. The type is different. This is a type 2, and then the second one is a type 14.
Is it just a single sensor that could be sort of like two different configurations?
That's a good question. Okay, when you go to the website and you go to not sensor overview, this one is probably falling into position sensor.
What did he say?
Why we have multiple types for the magneto sensor. So here we have geomagneto rotation vector. We have magnetic field. So let's take a look at this type here. Okay, there we go. This is the type value. So this is type 2, which is just magnetic field. And the other one is a type 14, which is a magnetic field uncalibrated. So one is calibrated, one is uncalibrated. That's why there are two types. Calibrated, I think the calibration is based on any type of bias, inside an environment. So you can basically have your mobile device to store the distortion, due to other factors. So this way, one is calibrated, which means it takes the distortion into consideration already. But other than that, the two types of sensors have the same type of values. So when we look at the values, we're not dealing with that here.
So it's a single sensor, right? It's just whether you want it to return you a calibrated value versus
Right.
uncalibrated value.
Exactly. And the unit is micro T, and is Tesla a unit of magnetic flux? Okay, I can just look it up. Magnetic field unit, and it's T. Tesla, you are correct. It is in units of Tesla. So getting back to this screen here. So this is really useful because the sensors are not returning just a raw value. It's not just a number where you have to go through all the conversion. It's giving you specific units already. Now let me just kind of go through this list here and see if I can find a light sensor, because the light sensor will be returning in either lux or some other well-known units. Light proximity and light. Okay, we got that. Interesting. Mine has got a barometer too. It's got a barometer sensor. It's got gravity, linear acceleration, rotation vector, step counter. So it has a built-in step counter, like a pedometer. It's already built into it. Has got a significant motion detector, geomagnetic rotation, and orientation. So it has got a pretty long list of sensors on the device.
So they're all from different vendors, or?
Yeah, they are from different vendors. So the vendors go from InventSense to AKM, InventSense, Avago, AVAGO, as the company or the vendor. Bosch, that's the barometer.
Yeah.
Qualcomm for gravity.
I wonder if there's a single vendor that sort of integrate all of these sensors together in a single chip.
Well, a lot of them can be combined, but most of them are just separate chips.
Yeah. Well, the barometer is kind of a strange one. I did not expect my phone to have a barometer.
All Android phones that are released with KitKat have barometers.
Interesting, but
Yeah.
why would you want to have a barometer on
Weather.
a mobile device?
More accurate weather.
Weather?
Yeah. You can also use it for, with a barometer, you can also get more accurate altitude measurements too.
Well, I'm not sure if it's accurate, but I mean, it's affected by your pressure in the air too.
Right, but
Yeah.
it would be more accurate
I know
than it would just with GPS.
Then would you?
I know with this, the barometer is also used for the step counter,
Mm-hmm.
That too.
because it's tied in. Every step you do, there's a pressure difference, so it can calculate each step as actually the device moving versus just the
But the barometer measures
accelerometer.
air pressure.
Yeah, air pressure.
But why would air pressure have anything to do with
It was
steps?
tied in. In order to get steps,
Right.
you have to use a special function which uses barometer.
It also has a proximity sensor, proximity and light. So the proximity and light sensor are combined into one. To basically, usually it's trying to see whether you're holding your phone like this or not, to detect whether the screen side is having some object close to it. But it's also a general light sensor. So when it's not detecting an object that is right in front of it, it can also be used to detect background lighting. And that's how your device can kind of automatically adjust the backlight so that it is using the right level of backlight depending on where you are inside the room, outside, dark room, and so on.
Yeah, but I think those are separate sensors. One infrared and one just a light sensor.
On mine, they're combined into one.
Because I see on mine, I have a transmitter, a receiver, and
Yeah,
a
on
light sensor.
Samsungs they're different. On Samsungs, they have there are two little windows coming out of it, and they are either at an angle or they're straight like this, and they use that to detect whether something is on top of the device or not. There was an advertisement in South Korea, so it's not even translated into English, where I would assume Korean woman was kneading flour dough basically, and her hands were kind of sticky and dirty, and then the phone rang. The phone rang, her hands were dirty, and then what she did was to use her elbow to just kind of go over the phone, and then the phone detected her elbow kind of just hovering over, and then the phone connected and used the speakerphone at the same time. Basically it's pre-programmed to basically say, okay, if an object kind of wave on top of it while a call is active, then it will pick up the call and also turn on the speakerphone.
Yeah, but that's a different sensor. It doesn't use the proximity sensor.
That's not a proximity sensor?
No, you can actually move your finger across the screen
Right.
with that much space above it, and it'll track your finger.
Yeah, but I think that in that advertisement, her elbow was pretty far away, not like this close. The thing is about it's not really just the Samsung that can pick up just your having something hovering over like this close. All of the phones using capacitive screens should be able to do that. It's just a matter of whether they process it and pass it on to the operating system and make use of it or not. It has to do with the nature of a capacitive screen or a capacitive sensor. So we'll take a look at that. Capacitive sensor. Okay. And we want to find a explanation. Oh, wait. Got something in the picture here. There you go. Okay, so basically when your finger is even just close to your screen, assuming that quote unquote you're grounded, but you are basically one big capacitor as far as this picture is concerned. So it's basically detecting a change of capacitance because of you being close to the screen. And using that change of capacitance, it can kind of detect where your finger is located. I'm not an electrical engineer, so I can't really kind of give you an explanation of how that works. Does anyone want to explain that? Nope.
I missed it. I missed what you meant.
Oh, okay. I was trying to find out, how it works, how capacitive sensors work in general. Let's go to this page here. Okay. So this is the data sheet of a particular chipset for capacitance sensor for human interface to electronic equipment.
I would assume that it just works based on the sensor is probably programmed for a certain range of capacitance, and probably just bases it off of whatever human capacitance is. So when you touch it, I don't know. That's when I've read about it in the past. That's when I've read about it. So.
Well, they have a brief explanation here. I can kind of go through this in a brief explanation. A basic sensor includes a receiver and transmitter. So we have transmitter here and a receiver here. So you basically have a flux electrical charge going from one going to the other one, and they're separated. There's an insulation in between. Bulk of field confined within TX and RX, so that refers to electrical field between the two plates, TX and RX. Each of which consists of a metal traces forming on layer of a printed circuit board. So basically, we have traces that is transparent between two pieces of either glass or some other transparent material, as shown in Figure 1. The AD714X device has a on-chip excitation source, which is connected to the transmitter trace of the sensor. So they basically have a charge to put onto the TX part of the sensor. Between the receiver and the transmitter trace, an electrical field is formed because the RX field is basically just waiting there and say, okay, I'm just sensing, the electrical field. Most of the field is concentrated between the two layers of the sensor PCB. However, a fringe in electric field extends from the transmitter out of the PCB printed circuit board and terminates back at the receiver. So that's basically what this is talking about. It's going out and then coming back in. The field strength at the receiver is measured by the on-chip sigma delta capacitance to digital converter. Sigma delta is basically a method to get to an analog value by successive approximation. It's basically saying, okay, is that value greater than or less than this number? Okay, if it is less than, then it goes here, and then it halves the threshold, and then it asks again, is it above or below this threshold? So it's basically using binary method or just division to zero into the exact value of whatever it's trying to measure. So in this case, it is converting capacitance to digital, to a digital value. The electrical environment changes when the human hand invades the fringe field. So this is the fringe field, with a portion of the electric field being shunted to ground instead of terminating at the receiver. So instead of going here, it is basically you're removing that field, and and so as a result, the RX field is going to change. It's not going to sense what it is supposed to. The resultant is decrease in capacitance on the order of femtofarads as compared to picofarad for the bulk of the electric field is detected by the converter. That's a very minute amount of capacitance, because picofarad or PF is already considered a fairly small amount of capacitance, and femto is a lot less than that. So that's how these sensors work. And you might think that, well, but that's, how can you tell? You can tell that something is close to it, but how do we know where the finger is located? That is done by a grid line. In other words, this is just a picture of one single one, but when you look at the screen, it actually has lines like these for the PCB, and it has lines like these also. So basically what the controller does is it will actuate one at a time. So it will actuate the TX here, and then the RX will sense, okay, do we see any changes? If not, it will turn off this one and then excite the next one, and so on. So by scanning, horizontally and vertically, it will be able to basically figure out where the center of the distortion is, or the center of the capacitance distortion is located. So that's how a capacitance sensor works. Now go ahead.
Wouldn't it be more effective just do all of the rows or columns at the same time, then find out which ones have less values at the end, then do the same thing on the.
But if you turn them all on at the
or
same
rows.
time, there's no way to sense all of these at the same time. Because I think they use the same RX, it's just that the TX is different. In other words, they use one single layer as the RX to sense how much capacitance is actually captured, but they use a different TX depending on which one is actuated. So it will basically scan horizontally and then scan vertically to find out. The other way they can do it is to have one TX like this and then have multiple RXs to try to pick it up. So this way, by activating one TX, you can sense You can sense the location, in this dimension, but you cannot sense it, in the other dimension. Just so you can just scan it in one single direction to find out, the actual location of your finger, or whatever that is close to it. This is different from a resistive screen, because earlier devices like Palm Pilots, they use resistive screens, which is kind of like this, except the screen itself is resistive. So where you make the contact between the two layers by measuring the resistance, in one dimension and the resistance in the other dimension, it can kind of locate where you make that contact. But the problem is when you have two contacts, sometimes if you have two contacts like this, it's okay. When you have two contacts like this, there's no way you can tell where your finger is or where the 2 points are located, because the resistance in that case is going to be a combined resistance, and there's no way to differentiate between which one location from the other. With a capacitive screen, it has the ability to do multi-touch, and that's why capacitive screens are considered better than resistive screens when it comes to mobile devices. Some of that stuff coming out of China, like Android devices for like $30, $40, they use resistive screens because it's less expensive. And it takes a lot of pressure to, sometimes to actually actuate something. Are there any questions about, how capacitive screens work? I mean, that's obviously it's not within the scope of this class, but it's kind of interesting. Any questions? Close this one. And Tesla is the strength of a magnetic field. It's a unit to measure the strength of magnetic field. Are there any questions about what we have talked about so far? Questions? Okay, this is really a useful slide because it tells you not only what type of information is returned, but also in terms of unit, what are we talking about? Because when you look at the rotation vector, the description or the value is the rotation vector along the x-axis. So this is x times sine of theta divided by 2. So it tells you exactly how to make use of the returned information. Yep.
When the information was listed on the screen, that was just Android's way of displaying an array?
You mean what we just saw?
Yeah, all the individual values. Or is that just a string like that?
You mean this part?
Yes. Looks like an array.
That's the result of toString.
TwoString.
Yeah, because just about any object has a quote unquote toString method, which is a method to make a human understand what that object is. And these are basically converted from a sensor object. I'm calling the toString method of a sensor object and get these strings as a result. The curly braces is a part of the output of toString because I didn't do any formatting at all. I'm just saying, okay, give me the toString value of this particular sensor, and I'll just put it into the list view, and this is what I'm getting. So it does give you most of the information that an end user can make use of. So that's including just the name of the sensor, vendor, version type, range, resolution, and also power. And I suspect power is in milliwatts. This is, so for instance here, basically the compass is measured in, basically it's 5 milliwatts. When it's active, it will consume 5 milliwatts.
So,
yep.
This list view, does it automatically come with a scroll bar?
Yes, a scroll bar is built into it automatically.
I can see the scroll bar.
Let me see if I can bring that screen back up here. It's just slow. Yeah, so there's a scroll bar. It can't really see it. It's really kind of here.
Okay.
So you can use your finger to scroll through the whole thing, because the list view has a port only about this big, but the actual content is much longer.
Right.
So the scroll bar is automatically, quote unquote, created So you can just basically use your finger to slide through the entire thing. Okay, and this is what this is the Bosch one. So let me just center the screen so you can see the Bosch.
Barometer takes nearly no power at all.
Yep. The resolution is also useful because you can now tell what is the next value. So this is the step detector. It's the vendor is Qualcomm, so it's actually this is a part of the processor. I would suspect it's a part of the processor chip itself, because the processor is made by Qualcomm. And if the vendor of the quote unquote step detector, which is probably just a software rendering of the same information that is coming out of the accelerometer, so I think that is actually integrated onto the same die as the main processor itself. It makes sense. If all the devices require this device, why make it a separate chip? Right.
I saw a gravity sensor.
A what?
A gravity?
A gravity sensor? Oh yeah, there's a gravity sensor. Let me just scroll to that part.
It is I think it's up and on.
Yep, there we go. You're talking about here.
Yeah.
Gravity sensor. I think these are all the same physical hardware sensor. It's just one is returning gravity information and the other ones are returning different type of sensors. So let's take a look at the gravity sensor in here. The gravity sensor will correspond to either motion or position. So let me see which one it falls into. Right here. So you can see that gravity sensor is going to return the force of gravity along the axes, along the X, Y, and Z axes. A gyroscope, on the other hand, is returning rate of rotation around the axis. So that's really helpful because one will give you a static number, like if your device is just like this, then all of the rotation, the gyroscope returns 0, 0, 0 because you're not rotating, you're not making any changes. But if you look at the gravity, that tells you the orientation because on a device, and let me just kind of on a device, when you look at the device in its correct orientation, the X is the one that is horizontal, okay, sideways. Y is the one that is vertical, up, and then Z is the one that is coming toward you. So that's the X, Y, Z axis of how these things are measured. So you have really a wealth of information that is already at your fingertip, basically. So every time you inquire, or you ask the sensor to report back, okay, something just got changed, it will send back a sensor event object. And within the sensor event object, you have these values. And depending on the sensor type, the value can give you, a different type of meaning, depending on the sensor type. Some will give you like only a few, values. Some other ones will give you like up to 6, possible values. I'm trying to locate one right here. This one gives you 6. It is the gyroscope uncalibrated. So we have rate of rotation without drift compensation, rate of rotation without drift compensation, and estimated drift around the x-axis, estimated drift around the y-axis, and estimated drift around the z-axis. So it does give you a lot of information. The other thing you want to also know is there are specific sensor types for gaming purposes as opposed to just regular, okay, I just want to know which way my screen is oriented. So if you go to position sensor, you can see that it has a game rotation vector. Specific for games. So this one gives you a rotation vector component along the x-axis, and it's a ratio, and that's why it has no unit. It's just a ratio. It's basically the sine, x times sine of theta divided by 2. And the other one is y, and the last one is z. It's the rotation vector component. Are there any questions about the sensors? No questions? No one seemed to be excited that we now know how to get to the sensors. Well, not entirely. Okay, what we did is, in today's class is to make it list all the possible, all the different types of sensors that we have access to, which is a good starting point. Okay, it's a good starting point because now at least you can assess your devices, your phone, your tablet, and whatnot, and say, okay, what can we do with this particular device? What type of information can I get out of the sensors? So in the next class, we'll talk about how to configure the sensors so that when there's a value change, it will alert your application and say, you know what, this graffiti sensor, the value has just changed. And you can also control the frequency of how often it can report back with an update. Now, obviously, if your device is sitting very still on something and there's no change, it's not going to come back with a notification. But what if you're waving it like this? Okay, how frequently are you going to get an update? Are you getting an update every 5 milliseconds, or are you getting an update every 50 milliseconds? That part is actually programmable. Okay, so we'll talk about that next time, and I think this is going to be quite interesting. It will be quite useful. A lot of virtual reality software. Oh, this I gotta show you guys. I know you cannot see it. Let me see if I can just bring up the application and then use the tool that I was using to bring it up. It's a very interesting application. Well, to me it is. To you, it may not be exciting, but to me, this is really kind of exciting because I can do this. There we go. Okay, so I'm going to plug this back in and see if I can display that. Okay, no screenshot because I not allowed it. Okay. There we go. I'm just waiting for the correct one. It's a sun tracker. So it's combining, the position sensor, the GPS location, and also the orientation of the device. It's basically telling me the sun should be coming in from that direction now.
Which application is this one?
It's called, okay, excuse my moving around here. Okay, if I go back to the home page, it's called Sun Surveyor.
Sensor.
Yeah, so if you look here for Sun Surveyor. Yeah, that's basically the application. So you can do it using a map. You can basically superimpose, but you can also do it through augmented reality. And the best part about the augmented reality part is you can set the date to something else, something other than today. And instead of tracking the current sun location, you can just look at the track of the sun through the sky. And then when you are using augmented reality, that shows you, okay, let's say, in June, okay, if I want to know in June or July, where would be, how would the sun traverse, through my backyard, I can now, use my phone and I can see that, oh, you know what, that tree needs to go. Or I want to plant a tree over here because I want my house to be shaded at a particular time of the day.
Now you know where the sun is in a windowless office.
Yes.
Well, I installed, 2 years ago, I self-installed a solar panel system. They sell these softwares and cameras, specialized cameras to try to figure out what is the
exposure
over the season or
Yep.
over the year.
Yeah, that app can basically do all that, but it's not handy. It doesn't really give you any optimal values or or a percentage.
Yeah.
But you can take your phone and really quickly you can just kind of go out and pick a particular time of the year, and you can just kind of look around and go, okay, I know the sun is going to follow this track, and there's a tree over here, there's a tree over here. So you know how much sun your plants will be seeing if you're planting, in a garden, or if you want to, shade your house. You can also use that information and say, okay, if I want to shade my house in July and August from the sun in the afternoon, then you can actually see it and say, okay, I need that tree to be at least 30 feet high, from this distance from my house. It's really useful. It's really, really kind of cool. It can also track the movement of the moon on top of tracking the movement of the sun. And why would you want to track the movement of the moon or track? It's for photographers.
Oh.
So you know how those photographers always have pick the best time of the year, like the moon is rising on top of, let's say, the Golden Gate Bridge and stuff like that. This is how they do it, because they can just basically go through that software and find out at what time on which day the moon or the sun is going to be full, partial and whatnot, and where it's rising out of. Really kind of interesting type of applications. Any other questions? I mean, that's a really good use of the sensors, because you're basically making use of your GPS location, because you need to know where you are on Earth in order to find out the orbit of the sun around it. But at the same time, you also need to keep track of the orientation. Are you facing north, east, southwest, and how far, as well as the tilting of the device, because that way you can integrate information from the camera and then superimpose the track of the object that you're trying to track on top of that. So it's a really good integration of just about all of the things that we have talked about so far. We haven't really talked about the camera yet, but at least now we know how the sensors can be used.
So phones start having finger print sensors, right?
The iPhones are starting to have it, but I'm not sure how many Android devices have it.
Okay. So, I was just curious whether the Android have any support for that yet.
Not yet. I do not see that as a type of sensor that is supported. So if I go back to the website and to the sensor array, there's actually an array or a table that shows you all the different types of sensors supported by a particular version of Android. I think it's here. So these are the types that are supported up to Android 4.0. And I don't see fingerprint at all. Maybe it's not listed as a sensor. Maybe it's for security under some other categories, but it's definitely not under here. I would not expect it to be under sensor, because it's not really reporting information on a continuous basis like these things are. It's really just a device for authentication purpose. And how it matches a database of fingerprints is the other thing. If it returns just a bitmap, it's not going to be very helpful. So it has some kind of internal logic to basically say, okay, here's a database of fingerprints that it is supposed to recognize, and it will basically just say, okay, whatever is being scanned by the fingerprint sensor is matching that item in the database. So it has to give you a fairly high level API already. Otherwise, it's not going to be that helpful. Does anyone know how the new iPhones do the fingerprint thing? Is it a scanning thing, or is it just you put your finger on it and it will automatically scan for the fingerprint?
I think you just put your finger on it.
You just put it there. You don't have to slide it.
I think that the slide is over the.
Now, from what I've seen, it's a sensor itself. You just put your finger on it, and it captures the necessary information.
Okay. Let's take a look. Images.
Doesn't look like anyone's scanning.
Yep, it's not scanning. It just you put your fingerprint on this quote unquote button, and it basically takes a picture of from the side, so you can see how your finger is contacting the glass surface. So your ridges won't get exposed, but the part of your finger actually that touches the glass will get exposed, and it's taking that information. Let's see here. Which means it's probably an optical kind of thing. There we go.
What it looks like too.
Okay, so that's an exploded view of what it looks like. So it has a glass where your finger rests on, and then it has a film of a filter of some kind, and then a sensor behind that.
And then a button below all that.
And a regular button below all that, yes. I wonder whether that button is pressure sensitive, because that can be useful as well.
Well, that piece of glass would have to be super strong. Because, I mean, people pressing the home button.
Yeah, but it's also small.
Right. So you're looking at the pressure, it cannot, because of the smaller surface, it cannot accumulate that much force.
True. But if you got mad enough, you could probably break it.
Well, take a sledgehammer to anything, probably break it.
The S5, Galaxy X5 have a fingerprint sensor, but you have to swipe it.
Okay. Yeah, this one doesn't need swiping because you can see the sensor itself is a two-dimensional sensor,
Yeah.
whereas the Galaxy S5 probably has a linear sensor, so you have to slide your finger. Anything that requires sliding doesn't work as well because some people slide faster, some people slide slower, and some people do not slide consistently. So it's fast and slow. This works a lot better because it's just you put your finger there.
The implementation's a lot better.
Yeah,
Yep.
I remember Apple claiming that this system is unhackable. Then, like a day afterwards, we got a proof of concept.
Nothing is unhackable.
But the thing is, if any company claims that something is unhackable,
That's
it's
just a
an
challenge.
open invitation to hackers. It's like, please prioritize and hack my devices first.
You can't jailbreak our stuff. It's just like it's the same company. It's like you can't install Mac OS on other computers because the disk won't allow you. That was easily proven not true.
Yep.
By several people.
Yep.
There's an entire community that do Hackintoshes.
Just because
They can't.
Yeah, exactly, exactly.
Yeah, I really don't see the reasoning behind a fingerprint scanner on a touchscreen device where you're constantly leaving a clear fingerprint all over the place.
It's a selling point.
It's a differentiation factor. How our devices are different from the other ones. You can do authentication by a magnitude of ways, and fingerprint is not necessarily the most secure way either.
People talk about how the Google Play Store is worse than the App Store because of quality problems, but the thing is that a lot of developers are jumping away from Apple very quickly and moving to Android. It's cheaper. It's way more sustainable. Now, I personally have an iPhone.
And you can choose your devices too.
Yeah, I have an iPhone, but the thing is Apple does stuff like this to help them regain market share. They are rapidly losing it to Android. I think Android actually surpassed them as far as total market share for all Android devices.
That is correct, but that's mostly, I think it has to do with when you choose something other than iPhones. Now you can choose between HTC, Samsung, LG, a magnitude of manufacturers, with various types of price points. If you want the El Cheapo, you got El Cheapo. If you want the super duper expensive and fancy, you have super duper, fancy and expensive, and everything in between.
I like the Apple's response to giving cheap phones was the 5C, and it's just $99. Okay, well I get the same features for nothing from another phone. It's just money to me, I think.
And then plus the jail breaking part of iPhones, they actively try to deter people from jailbreaking, whereas with Android, Android itself doesn't care. It's your carrier that cares.
Right.
Google phones, like Nexus 5, you can basically get it, rooted in no time because Google doesn't really care. They don't really do much to protect their phone from getting rooted. It's like, okay, it's your device, do whatever you want.
Part of the licenses that Android is developed under are GNU, so
but that only applies to one portion of Android. It doesn't apply to the Google part of Android.
right, true.
all the Google API stuff.
But the pricing model and then the business model is different too, because Google is not making money much out of the devices themselves. I don't think Google is collecting royalty.
Not
you
off
know,
the devices, but off the advertising on them, I'm sure.
advertisement and just collecting the information, is useful, because now they can sell your information to people who potentially want to advertise with Google.
Well, there's all the licensing fees for the Google services as well.
Mm-hmm.
Talking about
Play
like
Store,
Play Store.
Framework, all their special apps.
Yeah, but are you talking about like being a developer on the Play Store?
No, just collecting money from Android if the
Oh.
From
cell
vendors.
phone or tablet manufacturer wants to add their special Google Play
Oh,
market.
yeah.
Then there's those own licensing fees right there.
Sure, you can be on our market here, just cost you about,
Yeah, but that's not on the
$70,000.
device itself, So the business model is different. I mean, Google doesn't make their own devices. The Nexus 5 is made by LG. Okay, so it's not really.
And they sold off Motorola.
They sold off Motorola, but they retained some of the patents.
Yeah.
Yeah.
It's like we can't pick and choose, so we'll buy the whole thing, then just toss out what we don't want.
The only reason why they
And
bought
they still,
Motorola
and
is
it's
for
still a
patents.
good deal. And it's still a good deal.
Oh yeah, they got it. They got all those patents for super cheap comparatively.
Yep. All right. Any other questions? Anything that I can answer right now?
Did you fix the power server?
The power server. Oh, you mean the WordPress? No, I have not. I haven't taken a look yet. I was trying to fix my live distribution last night when I got
Broke it
home and-
again?
No. Sid has a very unstable live build package right now, so I can't really redo the live ISO at this point. So I'm still kind of stuck with the older version.
Oh yeah.
Yeah. All right, so I'm gonna stop the recorder.
You should drop